Shallots are one of the best horticultural commodities in Indonesia. Shallot plants can be seen whether or not healthy through leeks. Diseases of green onions include purple spots and leaf rot, anthracnose. Purple spot disease is caused by a fungus named Alternaria pori lsif, while leaf rot is caused by a fungus named Colectothreme glysporioides pens, Colectothreme cercinans, Burke, Bogle. In purple spots, the symptoms that can be seen are the presence of small white and gray spots, and in the middle there's a black dot and surrounded by yellow color. In order to improve the efficiency of visual identification of leaf diseases through a digital image processing approach, image processing was also developed to be able to classify plants based on diseases that attack plants. Image processing approach can be developed in order to help onion farmers classify diseases onions based on the image of leeks. Moreover, farmers can minimize the losses during harvest. The research objective is to propose an onion disease identification system through the classification of leaf images using the artificial neural network algorithm. Onion disease identification system through the classification of leaf images using the artificial neural network algorithm developed in our research has several stages: there pre-processing, feature extraction, and classification. The proposed schema, has shown in Figure 1. Data in the form of images of scallions were obtained in Beji District, Pasuruan Regency. The picture is taken using a digital camera, with a size of 500 by 200 pixels. With data on 60 leaves attacked by purple spots trotal, 60 attacked by leaf rot, anthracnose, and 60 healthy leaves. Before shooting using a camera, the leaves are placed in a black box first with the light of two 8-watt T5 lamps so that the picture gets good light. The analysis will be used in the design and manufacture of this image processing application as a classification of leaf diseases using artificial neural network, and from Figure 1 it is explained that the flow of this system starts from the input image data that has been taken previously. Then it will be processed at the pre-processing stage, namely improving image contrast, converting sRGB to lab, segmenting using clustering, grayscale images, and binary images. The next step is extraction of features, namely color features and texture features. After that, the data will be tested where there are two stages, namely training and testing. In training there are two stages, namely training features and training classes. Whereas in testing there are also two stages, namely the testing feature and the model, rule. Then the last stage is displaying the results of a trial in the form of information. The data used were 90 training data images and 90 test data images, which consisted of three classes, namely purple spotting, leaf rot, and healthy leaves. Aims to improve the quality of the image so that it is more easily processed at a later stage. The initial process is that the original image's contrast is improved, resulting in an image with optimal contrast. After the contrast is corrected, the image will be converted into an L*A*B image through the transformation of color components. Then the clustering approach will be carried out, which aims to find areas of leaves that have indications of disease. After selecting the cluster to get the area indicated by the disease, image segmentation will be obtained. The segmentation process aims to simplify the representation of images so that they are easier to recognize. The results of this segmentation will then be represented into values using feature extraction. After the segmentation process is converted to grayscale and binary images, feature extraction is calculating the value of the object's own characteristics in several calculations so as to produce data values that distinguish the image itself from other images. The features used are texture features and color features possessed by the image of leeks. This texture feature uses GLCM, gray level co-occurrence matrices calculations. GLCM is divided into several types, namely contrast, correlation, energy, entropy, variance, IDM, inverse difference movement, while the color features are obtained from the statistical characteristics of the two-order RGB values that indicate the image itself. color features are divided into a number of counts, namely standard deviation, kurtosis, mean, and skewness. The learning and classification process implements the artificial neural network algorithm with a backpropagation model. Backpropagation has strong and objective mathematics, so that it can form an equation and coefficient value in the formula by minimizing the number of errors in the system. Backpropagation itself is a multi-layer network architecture on n. In this model there are several neuron units called the input layer, several neuron units as the hidden layer. Backpropagation itself is a multi-layer network architecture on n. In this model there are several neuron units called the input layer, several neuron units as the hidden layer, and several neuron units as the output layer. After testing each image data test, the results will be calculated using the formula. On the results of the testing accuracy of 90 scallion images, it can be calculated that the accuracy of the test image values for 90 scallion images obtained an accuracy value of 91.1%. Future studies are expected to have more features in order to optimize the accuracy of disease detection. Disease detection is expected to be even more data variations with disease conditions that can be detected.